Hello, my name is Hannah, and today we will be talking about what makes a good nucleophile. This is something I struggled with understanding in my organic chemistry class, so I thought I'd make it easier for others to understand. We will start by explaining what is a nucleophile. A nucleophile donates its electrons to form a new covalent bond in a reaction. Any molecule or ion with a free pair of electrons can be a nucleophile, but some will be better than others. There are four main things to look at when examining the nucleophilicity. First, we have charge, electronegativity, solvent, and steric hindrance. First, we'll be looking at charge. The conjugate base of a molecule is always a stronger nucleophile. Therefore, it will have a negative charge. The higher the electron density, the more nucleophilic. If you look at these examples, we have H2O and its conjugate base OH-, and the arrow points to the OH- as the stronger nucleophile. We also have that for the next two examples. Nucleophilicity increases with increasing electron density on an atom. Next is electronegativity. The lower the electronegativity, the higher the nucleophilicity. If you look at a periodic table, the trend of electronegativity will be up and to the right. And right there, we will find fluorine. So fluorine is the most electronegative, and it is better to have a lower electronegativity because looking at fluorine, you will have the electrons very closely packed together. And looking at another thing like carbon, for instance, the electrons will be a little more loosely packed together. Nucleophilicity is the donation of electron pair. The less electronegative the atom, the less tightly held together those electrons will be. Next, we'll be looking at solvent. We have both protic and aprotic solvents. We'll be talking about protic solvents first, and protic solvents contain at least one hydrogen atom, and they are capable of hydrogen bonding. Some examples are water. Let me draw out water. So you obviously have the H, the O in the middle, another H, and then we have other things like alcohols, acetic acid, and ammonia. And ammonia is simply just nitrogen next to three hydrogens. Protic solvents favor the SN1 reaction and take more steps to complete. Nucleophilicity within polar protic solvents increases going down the periodic table. So fluorine is right up top when you look at the electronegativity charge, and we're actually going to be increasing going down. Okay? So we have fluorine at top, that's down. Fluorine, chlorine, bromine, and iodine. And so iodine will be the strongest nucleophile for protic solvents. Polar aprotic solvents do not have hydrogens and therefore are not capable of hydrogen bonding. These molecules are attached to a fairly electronegative atom. So for example, we have acetone, and we have DMF, which is very similar to acetone but with a nitrogen group. They favor SN2 reactions, and therefore the reaction rates are faster. For aprotic solvents, nucleophilicity increases going up the periodic table. So once again, goes up the periodic table, which is opposite for protic solvents. Okay, so you have iodine as the weakest and fluorine as the strongest nucleophile. Lastly, we have steric hindrance, which is also described as the bulkiness of a molecule. The bulkier the molecule, the worse the nucleophile. So if you look at these examples, we have on the right the most bulky, which has the 3 carbons connected. You have 2 carbons connected, you have a bend, and then you have 1 carbon connected. And so the one on the left will be the least bulky, and therefore the best nucleophile. There are other factors that may affect the nucleophilicity, but these are just some of the basics. Thank you for tuning in, and I hope this helped to understand nucleophiles. Thank you for watching What Makes a Good Nucleophile at Orgo 1 with Hannah.